Welcome everyone to the Solar Powered Spaceflight Solar in Space special topic webinar. My name is Abigail Jager. I'm a program manager with Solar Oregon, and this is a special topic presentation that we are providing today, just talking about how solar power has been utilized in spaceflight throughout history and how it differs and is similar to the solar panels you could get on your home or business. As I said, I'm a program manager with the organization Solar Oregon. Solar Oregon is a 501c3 nonprofit that promotes solar and storage adoption throughout Oregon. We do this through educational webinars such as this one, our How to Go Solar and Storage webinar, and a Comparing Solar Quotes webinar by hosting community events such as solar socials, the Go Zero tour, and our solar wine tour, and by providing some amount of advocacy down at the state capitol and helping people advocate for more pro-solar policies. Thank you so much for being here today, and hopefully this will not be your first or last event you attend with Solar Oregon. This workshop is also made possible by support from Energy Trust of Oregon. Energy Trust of Oregon is was created in 2001 by the state legislature in order to promote adoption of renewable um, energies and energy efficiency technologies. They serve over 2 million people in the Pacific Northwest who are customers of the investor-owned utilities Pacific Power, um, PGE, and Avista Natural Gas. Thank you so much, Energy Trust, for your continued support. Today, we're going to be talking about how solar panels have been instrumental in powering space flight and in our space exploration. And so without further ado, let's get into the presentation. So pictured here is Vanguard 1, which was launched in May of 1958 and was the first satellite to utilize solar power. When in space, retaining power for the spacecraft or satellite is vital. And since nearly the beginning of space flight, solar cells have been the way we have done that. Launched on the 17th of March, 1958, Vanguard 1 was the first satellite to have solar electric power. Vanguard 1 contained a 10 megawatt solar cells solar panel and was powered by a mercury battery and a 5 megawatt transmitter. And it was all powered by 6 solar cells mounted on the body of the satellite. So the satellite itself held the solar panels. And while this was a very early use of solar cells and solar power, scientists and researchers have been creating different prototypes and filing patents for solar panels and solar technologies for decades by this point. However, the first solar system for homeowners was not installed until the 1970s. And so this was far before that was taking place. And yet, even then, we realized the great potential that solar provided, particularly in spaceflight. So the Vanguard 1 proved that solar power was an ideal power source for any spacecraft. And since then, almost all spacecraft have utilized solar power in some form or another, and all crewed spacecraft have had solar panels on board in order to generate more power while in flight. Pictured here is Explorer 6, which was a solar-powered satellite. You can see those solar panels extending out from the body of the satellite in that image. And why I chose to include this as an example is that it took the first picture of Earth from space, which is shown on the right. So that is one of the very first pictures of Earth from space that was ever taken. And personally, I love to see it because I love seeing how far we have come since then in some of the images that have come out in the Artemis missions and the James Webb Space Telescope in recent years. And so after that, once we had proven that solar power was ideal for space flight and for providing power to spacecraft, the next step was to put solar panels on another planet, or in this case, the moon. Set up by the Apollo 11 crew in 1968, the Apollo Passive Seismic Experiment had um had solar panels that allowed it to retain power and have power as it was transmitting data back to Earth. The point of this experiment was to measure lunar shock waves caused by moonquakes or the impacts of meteorites or of human-made objects on the surface of the moon. Data regarding the strength, duration, and approximate direction of the seismic event were relayed to receiving stations on Earth, and the seismic instrument was able to do all that via solar panels that were extended out from the base of the probe. And as I said, this was set up by the Apollo 11 crew in 1968. And in this image here from the National Air and Space Museum, where a model of this experiment exists, you can see that solar panel extending out from the body on the bottom of the image. The actual Apollo passive seismic experiment is still on the surface of the moon. Maybe the crewed Artemis mission that is supposed to be happening in the next couple of years will clean that up for us, as it was shut down in the 1970s, but very cool that's still there and theoretically still generating solar power. So now that we've had both crewed space flight with solar and satellites with solar, and we've put it on the moon, the next step was create the next step for solar in space was the creation of the ISS, as solar was the ideal continued power source to power the International Space Station. The image on the screen shows what the ISS looks like with all of its panels fully extended. The ISS is the has the record of being both the largest solar panels in space and being the largest solar array ever constructed in space. So all the solar array on the ISS was not developed on the ground and shipped up to space. It was actually put together by astronauts that were already in space. There are 8 solar arrays in total on the ISS. You can see all 8 of them extended here. And in total, it is 112 feet long by 39 feet wide. The entire array wingspan of 240 feet is longer than that of a Boeing 777, which is 212 feet. And altogether, the 4 sets of arrays are capable of generating between 75 and 95 kilowatts of power. And for comparison, the average solar system size here in Oregon is only about 8 to 10 kilowatts. So the ISS is generating almost 10 times as much power as our home solar panels on average here in Oregon. So now, just because this is such a cool project, I'm going to talk about it a little bit more. So this is a close-up of what those solar panels look like when extended. And the wingspan and each one of these individual panels, each one of these individual arrays is approximately 73 meters long. The panels used on the ISS are bifacial panels, meaning they are double-sided and are able to generate power from both the front and the back. So they generate power from both the sunlight coming off of the sun, but also all the sunlight that is bouncing off of Earth's atmosphere back towards the panel. So you just get essentially double the power generation within the same amount of space. They also feature trackers that allow them to pivot and turn and follow the sun as the space station orbits around the Earth. The space station originally used rechargeable nickel hydrogen batteries in order to store the power that the solar panels were generating and in order to retain power during the 45 minutes of every 90-minute orbit that the ISS is eclipsed from the sun by the Earth. So they needed to be able to retain power when they were not in view line of the sun. The batteries were recharged on the day side of the orbit, is how that worked. And those batteries had a 6.5-year lifetime and were regularly replaced over the 20-year lifespan of the station. However, in 2016, as the lifespan of the station had gotten extended and we'd made some advancements in technology here on Earth, they were replaced with nickel. The nickel hydrogen batteries were replaced with lithium ion batteries that are expected to last until the end of the ISS program without any additional maintenance unless something were to go wrong, in which case, of course, they would perform the necessary maintenance. So that ISS is generating a whole lot of power, and what is all that power being used for? Um, First, powering all the science experiments. The ISS has a continued rotation of international astronauts all conducting research, and all of these experiments need power, and we need lights in order to keep these astronauts comfortable while they're hanging out in space. However, more importantly than that is that many of these experiments also generate heat. The life-supporting systems on the ISS, as well as the experiments, all generate a lot of excess heat that needs to be dissipated and dealt with in order to keep the ISS at a livable temperature and in order to prevent any of the more temperature-sensitive experiments from overheating as well. So the vast majority of power generated on the ISS actually goes to keeping it at a consistent and comfortable temperature. This is actually really similar to what we use the majority of our power for here planetside, as nearly half of the energy in the US goes to heating and cooling of homes and businesses. And just so that we can pay thanks to some of the astronauts currently or recently on the ISS, pictured from left to right, we have astronaut Jasmine Mogably serving microbe samples, and then we have astronaut Satoshi Fukara as he replaces components on a 3D biological printer. And then in the bottom row, we have astronaut Stephen Bowen working in the microgravity science glove box, and European Space Agency astronaut Andreas Morgensen inside the Columbia's laboratory module. So they're all doing really important work, and we definitely want to make sure that they're able to retain power and remain as comfortable as they can be in a zero gravity environment floating through space. And all the solar panels on the ISS really help make that possible. So, how has solar power used in space impacted us on Earth? So traditional solar panels we see mounted on roofs are typically monofacial solar panels, meaning they only generate power from one side. And this works perfectly fine on a roof where the backside of the panel is usually only a couple of inches off the surface of your roof. And so not much power or sunlight is hitting that area anyway. However, we have found usage for bifacial solar panels here planetside, primarily in agrivoltaic research. Agrivoltaics are when solar panels are combined with agriculture and ranching in order to provide extra shade and allow the agriculture lands to pull double duty. Bifacial solar panels, which, as I said earlier, means they have solar cells on both sides and can generate power from both sides of the panels, are typically used in this um, application as there is more space between the earth and the panels as they're typically raised up, and that allows sunlight hitting the earth to bounce back and hit the panels and generate more power, and for the panels to be able to tilt and generate power from all sides as they in some cases as they follow the sun, or even if they're just tilting in order to allow tractors and other equipment through. As I said, agrovoltaics refer to the combining of agriculture and photovoltaics or solar panels. Solar panels are mounted in agriculture and ranch lands, and crops are planted underneath the panels. The panels are then equipped with motors that allow them to tip to allow tractors and other equipment through. And in some cases, the motors are also equipped with sensors that allow the panels to track the sun and tilt in order to provide and receive as much sun possible throughout the day. Having these panels be bifacial allows them to generate more power from the sunlight bouncing up from the earth, as I said. And this is, and in case you're worried about all the plants and animals that now have solar panels in the fields, don't worry, this is good for the plants and animals too. Having solar panel sharing fields can help make plants more resilient to heat and drought, which means they require less water to grow to the same size, and in some cases can actually produce stronger yields as they are not being burned to the crisp by the sun. And this is especially important as we are having hotter and drier summers and experiencing more extreme heat events. In ranchlands, much of the same holds true, though panels typically have to be mounted even higher in order to prevent the wiring from any curious animals. However, the panels are able to provide extra shade, which is really good for any animals during the extra heat and during the long summer months. And the animals are still able to graze underneath and have no issue sharing their space. As I mentioned, in some cases, agrivoltaic systems will be equipped with motors that allow the panels to tilt better to better follow the sun. This allows the power to be maximized as the solar panels aren't forced to stay in one place and can literally track the sun. Pictured here on the screen is are the Stracker solar panels that have really brought this idea to its full potential. And one great thing about Stracker panels is this is actually an Ashland-based company, and they have developed an agrivoltaic solar system where the panels are mounted from one central pole and can rotate a full 360 degrees in order to follow the path of the sun. Pictured here are Stracker panels out at the R Table Cooperative in Sherwood, Oregon. It's a really great farm cooperative, and if you haven't been there to check it out, I highly recommend it. But this is the same technology that the ISS uses. The ISS was able to pioneer this technology, and we've then found ways to utilize it here on Earth. Maybe one day we'll have solar power plants up in the sky that are just tracking the sun 24/7, and we'll have a way to export that power here to Earth, though I think right now that idea is still science fiction. So, how is this all related to solar you can get for your home or business? Overall, the solar for your home is not all that different. And if we're sending solar panels out into space, you can be assured that your panels on your roof are perfectly safe. Your solar panels have been well tested. They've been able to withstand space flight and existing in space for long periods of time. And I know that whenever I've watched a rocket launch, that does not look like a peaceful way to leave the planet. So they're quite strong, and you are able to protect your roof and will be able to withstand many things coming towards it. Um, the biggest difference between your home solar panels and panels on the ISS is that your panels don't need to rotate. Instead, they will be mounted in a way that maximizes the amount of solar resource that your home receives. And this also means there are fewer failure points, as your solar panels will not have any equipment that could jam or otherwise cause issues. What's pictured here on the screen right now is the diagram of a basic solar system. And as you can see, there are really no movement points on it. The photovoltaic panels are mounted statically onto your roof, and it is just wiring connecting them to your inverter, microinverter, and home electric panel. There's no movement point, and that means they're unlikely to fail, and it helps your solar panels be long lasting, as we know you want you to be able to get your full money worth and get your full warranty amount at that 15 to 20-year warranty. If you want to learn more, I highly encourage you to attend a free How to Go Solar and Storage workshop. You can scan the QR code on the screen in order to find out when they're happening. This is a great free impartial workshop that we give here at Solar Oregon that just goes through everything you need to know in order to go solar with confidence and how to ensure your home is right for solar. We also cover battery storage and answer all your questions you have. If you feel ready to jump in though, you can also, oop, my slides are in a different order, apologies. You can also scan the QR code on the screen to request a free custom analysis and bid using the Energy Trust of Oregon solar bid tool, which will connect you with up to 3 contractors who work in your area. It does not commit you to working with any of those contractors, but will get you a free quote and bid from up to 3 contractors in your area. And now if there's any questions about this presentation, please use the Q&A box at the bottom of your screen. I'd love to get your questions answered. And while people are thinking of if they have any questions, I'm also going to launch a quick poll. Thank you for filling that out. I really appreciate it. I'm not seeing any questions come into that Q&A box. So I'm just going to thank you everyone for their time and for attending the webinar today. This was a really fun topic to get to research, and I hope you found it as interesting as I did. Thank you so much, and I hope you have a great rest of your day.